Good afternoon. My name is Jason Deese, founder and CEO of Flash, where we save lives and economies with weather analytics. Now that's the official tagline. The really cool one is we predict lightning. Next, please. So how do we do it? Well, in the past, the weather enterprise used hardware for advancement. Before satellites, we could not predict hurricanes, and then prior to radar, we could not predict tornadoes. But these hardware solutions have severe limitations such as reliability, data gaps, and most important, they have a limit on the real world problems they can solve. So welcome to the future, where Flash uses software-only solution to take algorithmic insights, AI and machine learning, and combine this with vast data lakes to solve the previously thought unsolvable. We started with lightning prediction. Hardware-based networks only show observed strikes, meaning they miss the all-important first strike 100% of the time. This is important because 40% of all injuries and deaths come from that first strike. Next, please. We also started with lightning prediction because lightning is a big problem getting bigger, as you can see from these numbers here. 22,000 wildfires started per year. I'm sure you've seen the $1.8 billion in losses in California this past year. 240,000 individuals struck, that's worldwide, and we will have a worldwide solution. $5 billion in insurance losses. So think about your high ticket items. A $250,000 piece of equipment. Studies show that if we cut the power to that prior to a lightning strike, we can greatly mitigate the damage to that piece of equipment. And then the one we're perhaps most excited about is the aviation sector. $1 to $2 billion in losses every year due to lightning alone in that sector. And I'll tell you in a moment why we're excited about that. Take all of these numbers and keep in mind that lightning frequency will increase by 50% through 2100 due to climate change. So all these numbers will be increasing. Next, please. So what do we provide? We provide the start of lightning. We have 15 to 25 minutes prediction lead time on that first strike. No hardware needed. Unlimited monitoring radius, so we can go across the entire United States and ultimately the world. Prediction accuracy of up to 99.6%. We have a patented algorithm. The patent has been issued that predicts the first strike with high accuracy. We focus on the first strike before a storm ever develops. But wait, there's more. Next slide, please. The same algorithm used to predict the first strike is used to predict the last strike. So right now, the technology is dumb as you can get, and I'm sure you guys have seen it. 30 minutes after the last rumble of thunder is the current practice before you can resume normal activities. At Flash, we feel we can safely cut that time in half so we can resume normal activities sooner. So think about the aviation example. Remember this statistic. The Boeing jet burns a gallon of fuel per second circling a runway. So we did pricing models with Southwest Airlines. If we can get those aircraft down safely just 5 minutes faster or in the air 5 minutes faster, then they're saving hundreds of millions of dollars in year in fuel costs alone, and that's just for one airline. Next, please. So what kind of traction do we have? Well, we participated in the Miami condo collapse. We were asked to give lightning forecast for that. We provided lightning forecast to rescue crews for a 5-day period after the collapse. This included the challenging forecast for the approach of Tropical Storm Elsa. We even got a shout out on CNN for the services we were providing. We also, this past month, participated at the Daytona race. We provided lightning forecasts for public safety of race attendees. We did have lightning that came on shore, and so we alerted race officials to that. We also provided DGM race team with accurate forecasts of the onset of precipitation to aid race strategy. So again, not only are we just doing lightning, but we're using our AI machine learning for other aspects, which I'll show you here in a second. And then at the bottom, high-level talks with numerous airlines and Gulf entities, really anything outdoors, but starting with the enterprise customers, which would be the airlines primarily. Next, please. So our AI machine learning framework allows for easy integration into a variety of industry-specific needs. So not only are we doing lightning, but we already have an automated tornado product that actually goes out and detects tornadoes. No humans needed for this, issues tornado warnings, and already rivals that of what the National Weather Service for their statistics issues. Wind, think about fleet management, precipitation, onset of precipitation, and then hail, hurricanes, and winter storms, all from this AI machine learning. Next, please. So the product you'll see in the upper left, the yellow and the red indicate the predicted lightning strikes far in advance of a storm. And then on the upper right, you see our tornado prediction algorithm. And then on the bottom is the onset of rainfall there at the Daytona race. But these are all just for you guys to see. At the end of the day, we are just going to be an API provider, data provider, lightning and severe weather prediction services across the entire world with no hardware requirements. Enterprise and consumer software lends itself nicely to integration, and then an agile infrastructure with our robust Redis and Lambda infrastructure for big data. We're going to use this AI ML integrations for tornadoes, winds, winter storms, and hurricanes. Next, please. So the ask, we raised over $1 million in Start Engine, which was crowdfunding in 6 weeks. That was the top 10 all-time and fastest raised for $1 million on there. We're currently in a Regulation D, having raised over $460,000 of $2 million, and this round is at 30 cents a share. Next, please. And so I'll be happy to take any of your questions at this time.
All right, opening it up to the floor. Go ahead, Nilesh.
Yeah, what is the underlying data that you use? Can you maybe help explain or understand what data do you utilize to get your algorithms and the predictions?
Yeah, we're using a whole host of big data. So that would be radar networks, satellite networks, observation data. We are on the underlying using a variety of hardware networks, but it's all feeding into our software solution.
And you get that by virtue of your partnerships, or is this in public domain? How do you?
Yeah, that's the beauty of it, is it's all publicly free. You know, already been paid for by the taxpayers, and so yeah, we haven't paid for any data. It's just all out there for free use.
Okay, awesome, thanks.
Cassandra, I think you're up next.
Sure, thanks, Jason. Great
Well,
overview.
A small thing I forgot to mention. Can you just introduce where you're from, at least in your first question?
Sure thing. I'm from Upheaval Investments. We're a Chicago headquartered generalist deep tech fund, investing early stage anywhere in the world, hardware and software. My question was just to learn a little bit more about how you're making money, the business model, and the go-to-market plan.
Right. So the go-to-market plan right now is to target the enterprise consumers first. We have talked to several weather entities that have done it the other way, and it's cost them. So if you come out with a consumer app, then it's harder to sell to the enterprise consumer. So, you know, we have a variety of ways to go about it, but we feel this software as a service and just feeding into the airlines, insurance, energy sector, utilities. We're excited about that. They reroute high power lines based on the weather, so we can make that more efficient. So enterprise consumers first, and then just selling that as a licensing product.
Thank you.
Awesome. Lydia.
Yeah, hi, I'm Lydia. I'm a partner at Next47, which is the venture arm backed by Siemens. We invest in B2B startups across the world. So thanks, Jason, for the presentation. So I had a question on basically how do you integrate with your customer solutions? Is it an API that you provide, or how do you actually give them the data whenever there's a lightning information that you need to share with them?
Yeah, right now it's an API. We actually are dealing in a lot of big data for the API, so it's almost rivals something like you would see with a gaming solution like Fortnite and stuff. So a lot of our initial development's gone into the streaming technology and allowing that API to support that, which we've done. So, but yeah, we're trying to be as agile and flexible as it can be so that we can integrate with as many partners as possible. So APIs is the way to go.
I have a question. This is Duane York from Cityside. Given that you're pulling data from, you said sources already got paid for, so public domain, so to speak, what kind of IP protection do you have?
Well, the IP protection that we have is on the algorithm and the process that we use. And so, you know, there's nothing proprietary about the data that we're using. It's just in the way that we're using it. And so the process and the actual algorithm itself is unique. And so we have protections on those.
So did you file patent on those?
Yeah, that patent has been issued. It was issued
Okay.
in 6 months because there wasn't really anything like it. So it was issued very quickly.
Okay.
Just a quick
What-
question. Oh, I'm sorry, just a quick question. So does your solution predict the dry lightning? This is a big concern in western part of the US. So just wondering about that.
Yeah, it does. So fortunately, our solution, it doesn't depend on what's going on at the surface. It actually looks a loft higher into the atmosphere. And so it doesn't matter if any rain's coming from that, the dry lightning, it can detect it just as well.
Okay, thank you.
Mm.